So as we work in to polygons, the simplest polygon, in other words, if we talk about closed figures, is a triangle. You have to have at least three non-collinear points to create a closed shape. So a triangle is the simplest. So when it comes to triangles, let's see what we got here. We'll pause a second. So when it comes to triangles, let me click over here to this link, see if we can get this to work here. So one of the things to create a triangle, see if we can get this all here to kind of do its thing. So click on that dot. I kind of rotate this over this way. Click on this dot, rotate this way. Notice that we have a three-sided shape. Notice how one of the keys to creating a triangle is when you add two sides, it must always be greater than the third side. So notice that 3.1 plus 2 is clearly greater than 2.5. 2.5 plus 2 is greater than 3.1. And of course, 2.5 and 3.1 is already bigger than 2. Now, if I want to kind of change these shapes to be a little bit different, say if I do 4.3 there, um, let's let's just keep that as a 2. And we'll call it 2.1. If I drop that down to say 2 or 2.1, be fine. Notice that if I look at this, well, that's too close still. Let's make this down to like 1.5. Now you can kind of see clearly. Notice that 1.5 plus 2.1 is only 3.6. Notice how that's smaller than 4.3. Notice if I try to connect these three sides, I have to connect them at the endpoints. And notice that these two endpoints are not going to, they're not going to touch. So there's no way to create a triangle if two sides added together don't create a number bigger than the third side. So let's make this 5, make this 3, or call it 4, and we'll make this 3. So 3, 4, 5. 3, 4, 5 is a really common triangle. So you kind of see these circles overlapping. This helps me understand where they're going to meet at. So if I bring this up here to where the green line intersects, bring this up here where that intersects there. So you kind of start to see that, this is not perfect here for me, but you kind of start to see that we get close to a right angle. Technically, if I did that correctly, it should be exactly 90, but it's hard to get this stuff just really get them on top of each other. So you can't get that to do just perfect there. So they look close, but not quite. But 3, 4, 5 is going to be, if I sketch it, notice how that should look more like a 90-degree angle, and it's really, really close. Let me get these out of here again. So that comes there. I bet you wonder if I can get that there. I just don't have it steady enough in. It's about as close as I can get. But notice how 88.5 is really close to 90. So if you have three line segments, you can create a triangle. The catch is two sides must always add to more than the third side. So we have to pick up on that as we move forward. So types of triangles. We have a scalene triangle. What that means is all three sides are different lengths, which means all the angles are different. And there's no symmetry either. An example of a scalene triangle would be 3, 4, 5. But notice how we just talked about 3, 4, 5. All sides are different. It's a scalene, but notice how, based on the angles, it has a special name when it comes to angles. So right now we're talking about based on sides. So a scalene triangle means all three sides are different lengths, which means all three angles are different. An isosceles triangle, two sides are equal, two angles are equal, and there's one line of symmetry. So they're talking about 5, 5, 8. Well, if I go up to my math tool, I can't do probably 5, 5, 8, but let's say if we do 2, 2, 5 or something. No, so let's go 3, 3, 5. Wish I could just type that in. So 3, 3, 5. Yeah, that should be right. Let's just go 3, 3, 4. That'd be good enough. So notice how I have two sides are equal. So I get this to come into play here. So if I draw this, so notice how I can bring this endpoint or vertex, if you will, over here, bring this one over here. Oops, click on this one. Come on now. Grab that one, bring it over. Notice that in a scaling triangle, again, you should be able to see that these two sides are equal, but actually, both of these angles would be the same measure as well. So th this is basically 49. This is 49. I'm just having a hard time getting those little spots right on top of each other. So, but if these two sides are equal, then these two angles are actually equal in theory. It's just hard to do that with my dragging. My hand just can't quite get there. What if I make them a little bigger? I didn't even think about that. Huh. Bring that down a little bit. Nope. Bring the green one down a little bit. Can't get that green one. So anyway, yeah, let's do the red one. Can't get the green one to even click. And close. 47.847. But so in an isosceles triangle, two sides are going to be equal, and it's going to create really two angles equal as well. So there is going to be a line of symmetry as well. So if I go back to my drawing, notice how there is a line of symmetry here. So if I draw a line through here, see if I can create a little line somewhere. So if I draw a line straight down, notice how this side and this side kind of mirror each other. So there is a line of symmetry there. If I drop that down, that each side should kind of mirror itself. Okay. So we have an equilateral triangle, which means all three sides are equal, which means all three angles should equal 60. And there's actually three lines of symmetry. So they're saying like 6, 6, 6. Let's see what we can create over here using my tool. That's the wrong one. So if I can clear this off here, where's my eraser at? So if I can find my sides again. So if I say 3, 3, 3, whoa, come back here. So if I try to, let's see here, keep having auto scroll go on here. So if I can bring these up here to this spot, you should see that the angles should be really, 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 really close to 60. So 60.7, 59.3. So again, we're kind of getting that going on here. Let's see here. So, okay. So when we talk about sides, we have a scaling triangle, an isosceles triangle, and an equilateral implies sides as well. All three sides are equal. Based on angles, there's what's called an acute triangle, which means all angles are less than 90. A right triangle means exactly one angle is 90 degrees. An obtuse triangle means exactly one angle is greater than 90. So one of the things we're starting to pick up on is if you add the three angles of a triangle, that will always add up to 180 degrees. So a triangle can belong to a type of side and a type of angle. So if we talk about triangles, we can call them like right isosceles, so forth and so on here. So keep that in mind. And as we mentioned, for any triangle to exist, the sum of the lengths of any two sides must be greater than the third side. That's what I've been kind of trying to hammer home. So as we were saying here in our drawing, no set 3, 4, 5 creates a triangle because 3 plus 4 is greater than 5, 4 plus 5 is greater than 3, and 3 plus 5 is greater than 8. So this does generate a triangle as we see. So when it comes to working with triangles, we may come across some examples here. Let's see how many examples we have here with triangles. We just have this one. Okay. So one of the things we pick up on is, let's see here. We'll pause this and put this example in a different video.